Hello yours, welcome to my channel. So with the previous video we completed the first topic in the control systems, and in this video we are going to discuss about some block diagram reduction techniques. And before going to them directly, one should know what exactly is the block diagram and why the block diagram reduction is necessary. So if you see, any control system or any system can be represented by a set of blocks. Till now we discussed the open loop function, the closed loop function, I mean the feedback connected, and each block, the system may not have only single set of blocks, it may have more than one blocks where each block will have a separate respective functionality. So if the input is 1 and the output is 1, and between the input and output, instead of transfer function giving directly, there may be the equivalent representation of the transfer function in terms of blocks, which means there may be several blocks present. Set of blocks will be present from input to output. So to obtain the transfer function, that is the final state of the system should look like an input and an output, so that the transfer function of the system will be present in between. So with that, you can simply say that output and or output or input with that relation, that is output Laplace transform of output equal to transfer function into Laplace transform of input. So these are the basics till now we had learned in the previous videos. Now to reduce those set of blocks into a simple block, we need to follow set of instructions or rules that are present. So in this video we are going to discuss them about the block diagram reduction rules. So let's get started and not get wasted time. So you can see, so here these are the I will discuss about 7 basic important rules that are required and more than enough to reduce any block diagram. And in the series of videos coming, we are going to solve few examples that are given in gate, and some examples which will contain a numerous number of blocks and which will involve all the rules that we are going to discuss in this video. So if you see, this is the first rule, that is combining blocks which are in cascade or in parallel can be reduced into this equivalent form. So to write the equivalent form, I will give you one trick, that is you assume an input here, let me take it as x, and output as y. Then in both the cases, that is the reduced form of the block diagram and the initial form should have the same input and same output values. So let me give an example here, that is if I take x as an input, then the stage I will get here is x into g1, and if this is given as input to g2, then here I will get x g1 g2. So this is the output, that is x g1 g2 for this state, and here the input is x. So let's try this here also. Since these two are in cascade form, we can multiply simply as g1 and g2. Now if I give x as input, then the output is simply y, that is equal to x g1 g2. So you can observe the output in both the cases is same. So instead of writing these two blocks side by side, you can simply write as product of them, that is g1 and g2. So this is one and first important rule that is everyone should know to reduce the block diagrams in the control systems. So if you see here, these two have the same initial point and same final point, that is the summing point. So you can say that if two resistors are said to be in parallel, then the potential difference between those two should be same. So you can relate this topic, the topic you can relate here. So you can see that here x, then the output here is x into g1 and the output here is x into g2. If you add them, then you will get output, final output as x into g1 plus x into g2. If you take x common, then you can write that as x times of g1 g2. Now if I simply write here the same, that is if I give x as input, then the output is x into g1 plus g2. So these two cases the output is same. So you can simply represent this parallel block directly like this, as sum of two gains or sum of two functions. So here we are moving to the next rule, that is a moving summing point behind or behind a block. So you can see that, let me take two inputs, that is x and y here. So x minus y into g is my final output. So if you move that block of transfer function g forward, then how it will affect. Now you can see that you have to add one more block in the second one also. So how is, here the output is x plus x minus y into g. So here you can see, if you give x as input here, then the output here is x into g minus y into g. So you can simply write this as xg minus yg. So you can take x common, g common, then it will be g times of x minus y. So if you look these two carefully, the output obtained here is equal to the output obtained here. So if you move, if there is any case that the block diagram will be simplified, uh, by taking a step that if you move the transfer function before the summing point, then it's better to write like this, or you should write like this. So going to the next slide, that is moving a summing point ahead of the block. So summing point is here and the gain block is here. So if you want to move this block after the summing point or ahead of the block, I mean the summing point, you want to shift the summing point before this block, then this is the necessary reduction. So let's check this with two set of inputs. That is, if I give x as input, then here I will get x into g minus y. So final output is xg minus y. Simply you can check here, x minus y by g into g. So I will get gx plus g and g get cancelled, minus y. So I will get the same output as here. So you can read, if you want to move the summing point ahead of the block, then you have to write that like this. So next, fourth rule is moving a pick off point before a block, or sorry, behind the block. So here you can see this is the joining point, and here if you give x, then we are getting x here and xg here. So if you want to move that aside, I mean if you want to move that breaking point after that block, then see, you have to add, as you are going right side, you have to divide with 1 by g. That is one trick you can remember. If you want to move the breakaway point from this from front to back, then you have to divide with g. If you want to move from back to front, then you have to multiply with g. So let's check this. So here if I give input x, then I will get the output as xg, but for the second set I have to get the x as input. So if you divide with g, then you will get x as output. So in this way it will satisfy. Similarly you can check for this also. If I give x as input, then my output is xg, and here also I should get xg. So here if I give x, then here I will get xg, but if I don't add this block, then I will simply get x. So I have to get xg, so I have to multiply this with g. So in this way you can reduce. These two cases are also very helpful in simplifying the block diagram reduction. So getting to last set of formulas that we have already discussed in our previous videos, that is, this is called as a negative feedback system, or you can, if here it is negative symbol, then it is called as negative feedback system, and the final output function is, or the output is g by 1 plus gh. So if here if you use the positive feedback, then I already explained that it is g by 1 minus gh. So in this way you can simply, if you see any feedback system like this, simply you can write like this. So similarly this is also same, that is unity feedback system. If h becomes 1, this is the familiar case we will observe everywhere, like buffer circuits, etc. So if you find feedback as 1, then you can simply write, instead of h you can multiply with 1. So this is called unity feedback system. So here this is not useful all the cases. Rare cases we will use this, but this is called as splitting of summing points, or not exactly splitting. If you have 3 inputs, then it is called splitting. This is called as swapping, since addition will not follow any order. For example, a plus b plus c is equal to a plus c plus b, or both the answers will be same. So instead of a, suppose x and y are there, x minus y minus some z is equal to x minus z minus y. So both the cases the output will be same. So you can swap summing points. If there is no block connected in between them, you can simply swap whatever you want, you can do with that summing points. So I think you learned some rules which are more than enough to reduce any block diagram. So from the next video, let's get started doing problems, so that you will get more clear. So that's all for this video, and thank you for watching. Please subscribe to my channel for more videos.